Okay, so um, the video ended and I didn't realize it. So let me explain what happened. I started the Charge the Demo 2 class and I did the whole class and I ran it. And here is the result right here. Okay, I'm just going to, this is the code. To my, okay. And I wrote it in the nano, which is, let me clear this and Charge Demo 2 Java, and here it is. And then I run it. About every 30 minutes the thing, the video scans also. Let me just make text bigger. I need to make sure that this is not update. It shouldn't update the profile anyway. That's exactly what I did not want to happen. Okay, so let me just, all right, here we go. So we were reading booleans, and let's just continue. All right. Java has a primitive type called booleans. For logical values, it can have only two possible values, true or false. And this is the return type by all. This is the type returned by all relational operators, as in the case of it A smaller than B. Boolean is also a type required by the conditional expressions that govern the control statements, such as if and or and for. Here's program that demonstrates the Boolean type. And so we're going to create this program in the nano. Okay, could technically just copy and paste, I believe, but we're not going to do that. Okay, so let's go back to the nano and start writing. Bool test is what's going to be the name. What just happened here? Okay, so this is getting really, I don't know why this is not working. Bool test.java. There we go. All right, and so it says demonstrate Boolean values class bool test. Let's do public static void main string. Okay, and let's start typing. So Boolean b equals false. Okay. And see if it remembers what I copied here before. No, it doesn't remember. So let's start the mark. Alright, system out that print line. Okay. B is plus some reason there is like a okay. B, and let's just copy until here. There we go, and there we go. And let's introduce one of these. Okay. I know that I'm on 5. The reason why I use this one is because it gives me the time, and I know that I'm on 5:30. I gotta stop the video. Okay. B, and then B equals true, and then let's paste again. System print line. Oh, that's the focus thing, but haven't used it in forever. Okay, so B is plus B plus, oh no, let's leave it there, because there's actually another print statement coming. And now a boolean value can control the if statement. Okay. If B, since B is what equals true, we can just use it like that. If true, and then let's print the system print line. This is executed. B, now we set it to false. Okay, if B, which is false, of course, system dot out dot print line. Oh my god, did I just do that? I can't believe I just did that. Wait, I think it's like delete. Wait a minute, delete the character at the cursor position. I think it's like in front of the cursor position. The character at the cursor position. Change the current position. Okay, so I thought you could delete like end the current line, the beginning of the current line. Okay, it's not what I thought, but I'm gonna do it anyway just because I gotta remember to do this every time. There we go. This is not executed, and I believe I didn't make any errors. let's go up. Okay. Outcome of a relational operator is Boolean value. And we copy and paste again, system and print line. 10 and 9 is plus 10 greater than 9. Okay. And then I can't believe did I not do that? Oh no, I didn't do it. Alright, so let's save it. Okay, let's get out. Compile bool test.java, which should be visible here. Where did it go? Oh, it's writing them on the top. So it's right here. It is right here. Right here. This is where it was added. Okay. And now we're going to compile Java bool test in the bool test class. You can see right below my camera. And now we're going to run Boolean test. There we go. And again, I should have put the, you know what, let me be anal about this and I just do it now. Plus it gives me a chance to try the spacing. Alright, let me go to the end of this. Oof. Oh my god, I love that trick. And now let's do line break. Save it. Boom. Exit. Java. Okay. Boom. And let's just run it. There we go. And now there's a space underneath the result. Good. I like it like that. Okay. Alright, so now let's clear that again. And let's go back to our reading and see what the rest of this is. Alright. Okay, third, no. There are three interesting things to notice about this program. Okay, so let me move myself out of the picture, okay? There are three things to notice about this program. First, as you can see, when a Boolean value is output by print line, true or false is displayed. Second, the value of a Boolean variable is sufficient by itself to control the if statement. There is no need to write an if statement like this, if b equals true. Third, the outcome of a relational operator, such as less than, is a Boolean value. This is why the expression 10 is greater than 9 displays the value true. Further, the extra set of parentheses around 10 greater than 9 is necessary because the plus operator has a higher precedence than the greater than operator. Alright, so a closer look at literals. So let's go ahead and scroll up. Literals were mentioned briefly in chapter 2. Now the built-in types have been formally described. Let's take a closer look at them, at the literals. Integer literals. Integers are probably the most commonly used type in a typical program. Any whole number value is an integer literal. Examples are 1, 2, 3, and 42. These are all decimal values, meaning they are describing a base 10 number. Two other bases that can be used in integer literals are octal, base 8, and hexadecimal, base 16. Octal values are denoted in Java by a leading 0. Normal decimal numbers cannot have a leading 0. Thus, the seemingly valid value 09 will produce an error from the compiler since 9 is outside the octal 0 to 7 range. A more common base for numbers used by programmers is hexadecimal, which matches cleanly with modulo 8 word sizes. All right, let's scroll up a little bit. Okay. Such as 8, 16, 32, and 64 bits. You signify a hexadecimal constant with the leading 0 minus x. Or 0 dash x, I'm not sure. So 0x or 0x. The range of a hexadecimal digit is 0 to 15. So A through F are, or A through F, capital or lowercase, are substituted for 10 through 15. Integer literals create an int value, which in Java is a 32-bit integer value. Since Java is strongly typed, you might be wondering how is it possible to assign an integer literal to one of Java's other integer types, such as byte or long, without causing a type mismatch error. Fortunately, such situations are easily handled. That's because of unboxing and autoboxing. So let me get back in here. Okay, so unboxing and autoboxing are used by Java with the wrapper class, which go by the name of the numbers, the full name of the basic classes, right? Like integer, the wrapper class integer is spelled integer, not just int. And double is spelled with a capital T, long is spelled with a capital L, byte, short, etc. So it's pretty cool. All right, so let's go ahead and keep reading what the book is saying. So it says, fortunately, such situations are easily handled. When a literal value is assigned to a byte or short variable, no error is generated if the literal value is within the range of that target type. An integer literal can always be assigned to a long variable. However, to specify a long literal, you will need to explicitly tell the compiler that the literal value is of type long. Oh, wait. No, he's talking about casting to an upper value. You can it can implicitly upcast, but you cannot implicitly downcast. So a short a byte will be upgraded to an int, which is what he was saying earlier. Okay, so now an integer literal can always be assigned to a long variable. That's because you're upcasting and you know it can be done implicitly. However, to specify a long literal, you will need to explicitly tell the compiler that the literal value is of type long. You do this by appending an upper or lowercase l to the literal. Now this is for hexadecimal literals. Okay, for example, 0x7ff, they're like 10 or 11 f's, L. Alright, next page. Okay. And then all of these things. 92233372033 is the largest long. Okay. An integer can also be assigned to a chart as long as it is within range. You can also specify integer literals using binary. To do so, prefix the value with OD or OB for binary, or I should say 0. For example, this specifies a decimal value 10 using a binary literal. Okay. Int x. See, these little things, I didn't know that. And I'm certified in Java, but the course that I took was an off-fluff course, went straight to the point to give you the most useful information of almost all the major libraries of Java that are typically used in programming. And so there's like few details I didn't know. So this is why it's good that I'm going through this book, because this book is very thorough. You know, the Java complete reference 12th edition guide. Pretty good stuff, man. This is great. The definitive Java programming guide. This thing is great, man. Okay, so let's keep going. This is so good. Among other uses, let's scroll up the page. The addition of binary literals makes it easier to enter values used as bit masks. In such a case, the decimal or hexadecimal representation of the value does not visually convey its meaning relative to its use. Oh, let me do something here. Hold on a second. Let me do a little pause. Okay. All right, so we're back, and let's get back to business. And let's get to class. All right. So magnifier, come on now. There we go. Okay. So, by the way, I should hold on a second. I should close the browsers because I'm not using the browsers. I don't know why I have those things running in the back anyway. I shouldn't have them. Okay. Very well. Because that's just taking space and memory and all that. Oh, but I also have running TextMate, and I love TextMate, by the way. Okay, I'm missing out, so let me do this. IntelliJ IDE, let me close that too. There we go. And I'm going to close TextMate. Okay, and finally, I'm going to shut down GitHub because I'm not using it at the moment. And I think that's it. I think the rest we are using. We're using the rest. Okay. Alright, okay. I'll password. I'm also quitting that. Okay. We can get back to getting this done right. There we go. Now that's much better. See, the system is much faster. Okay, so now let's come back. See how much faster? This is pretty good. I had too many heavy processes. Okay, so among other uses, addition of binary literals makes it easier to enter values used at bitmaps. In such a case, the decimal or hexadecimal representation of the value does not visually convey its meaning relative to its use. The binary literal does. You can embed one or more underscores in an integer literal. Doing so makes it easier to read large integer literals. When the literal is compiled, the underscores are discarded. For example, okay, oh yeah, I love this because it makes numbers easier to read. It's pretty good. For example, given int x equals 123 underscore 456 underscore 789, that is supposed to be read as 123,456 789. The value given to x will be 123,456 789. The underscores will be ignored. Underscores can only be used to separate digits. They cannot come at the beginning or end of a literal. It is, however, permissible for more than one underscore to be used between two digits. For example, this is valid. Okay, so in this example, he actually has two underscores right here between each number, between each digit. The use of underscores in an integer literal is especially useful when encoding such things as cell phone numbers, customer ID numbers, part numbers, and so on. Wow, that's true. And I should cut the video soon. They're also useful for providing visual groupings when specifying binary literals. For example, binary values are often visually grouped in 4-digit units as shown here. Int x OB, that is decimal, binary decimal, 1101 underscore 0101 underscore 0001 underscore 1010. Nice. Okay, so let's read about floating point literals, but let's finish the video and continue next. Cool beans.